Let's start with sedimentary rocks. The person on your screen, Mrs. Kolowick, she was my intern teacher a number of years ago, and she put this together, so I've used it ever since because I like her notes and it worked out very well. So let's start with your objectives today. Explain the process of compaction and cementation, describe how chemical and organic sedimentary rocks form, describe how clastic sedimentary rocks form, and identify 7 sedimentary rock features. Fun facts. Sediments are loose fragments of rock, so little pieces of rock and organic material that are stuck together that result from natural processes. So they're broken up by natural processes. Most sedimentary rock is made up of different types of sediment. You have a number of different types of pieces that are sealed together to make up your sedimentary rock. And it's characterized by the source of the sediment. So wherever the sediment came from was moved to, and the condition of that sediment, that's what we classify our sedimentary rocks. It's also how it was deposited into that area that helped it form that rock that helps us decide. Formation of sedimentary rocks, the 2 main processes. So we've talked about this a little bit, so let's go a little further. First of all, compaction. That's where you have your sediments are squeezed and the pore space is reduced by weight and pressure. In other words, again, going back to the idea of a snowball, you have a pile of snow, you crunch it, crunch it, crunch it. What you're doing is you're taking out all the space in between those snowflakes and you're crunching them together. So you're reducing the weight and the pressure that comes with it. Now, cementation is where it's glued together, usually in a rock by minerals. And the water helps, the water will flow through a rock, leave its minerals behind, and they'll help to glue that mineral together. Now, in a snowball, usually it's ice and water that freeze that makes a snowball hold together. So it works better to make snowballs with your bare hands and not your gloves. There are 3 main classes of sedimentary rocks. There's the chemical. That's where you have water that evaporates, and as evaporates it leaves behind minerals. Those are the ones that are left behind are called evaporates. You have organic sedimentary rocks, which are formed from the remains of plants and animals. And finally you have clastic, and that's where pieces of sedimentary rock are cemented together. So these are actual chunks of rock, as you can see in the picture, that actually come up and stick together and form a new rock. Now, we talk about clastic sedimentary rock. They're classified by the size of the sediments. So when we have a conglomerate rock, those are very large fragments cemented together by finer, smaller pieces of sediments. If you have breccia, fragments are angular and have sharp corners. Sandstone is sand size. Now, I should explain before I go any further that when we talk about sand and clay and those kind of pieces and boulders, they're actually pebbles, are all sizes of rock. They really are. They're actual size sediment of rock, size of the sediments. So if I say that there's pebbles, they're actually the size to the pebble. In this case, sandstone, there's sand-sized grains that are cemented together, and shale is clay-sized particles that were cemented together and compacted. Now, it's a tendency occurrence of air and water to separate sediments according to their size. So if the faster current's moving, the bigger the stuff it's going to move. So as that current slows down, it's going to dump the big stuff and carry the small stuff. So if we were to look down a river where it starts out at this end, you're going to have all the big stuff drop out as the river starts to flow, and as you go down the river, you're going to see the smaller and smaller stuff. Also, along with every time those rocks are moving, getting forced down the river, they're tumbling and pounding and running into stuff, and each time they're breaking and sanding off the corners. So by the time they get down to the bottom, they're much smoother, finer particles, and then they are up at the top where they're rough and angular and real sharp. Now, sedimentary rock features. Stratification is the layering of sedimentary rocks. Layers vary in thickness, so each one can be a little thicker, a little thinner, depending on how long they were laid down. And this occurs when conditions sediment deposits change. So we could have an area of big deposits, so you have a lot of years of deposit. We have a very long, big, long band. But then you can have a small year where there was only just like 10 years of that, and then a little small layer. And that happens a lot depending on what the conditions do outside as the environment changes, so do they. Massive beds occur when there's lots of sediments in one area, obviously. Cross-bedding and graded bedding. Okay, now, looking at picture A and picture B, we have a difference. Cross-bed slanting layers usually in sand dunes and riverbeds, so you have that layer upon layer of rock. Graded bedding varies in size and the kinds of materials deposited within a layer. In other words, think of it as you have one layer, next layer, next layer, next layer. Whereas cross-bedding, if you look above, has those layers and then there's a layer of silt and then those layers start over again. On the bottom, graded bedding means that the whole thing is graded out by the bedding itself. Ripple marks caused by action, wind or water on sand. Obviously, it was once part of a beach or a riverbed. You have a very nice picture of ripple marks and mud cracks in your book. Fossils and consecrations, sediments pile, plants and animals' remains get buried and get stuck below, so we get to see what they look like. And that would be the end of our slides. Hope you enjoyed it.